Hey, ladies and gentlemen, Mr. Clare is coming at you with another version of Shop Talk. Today, we're going to talk a little bit about Square, whether we're talking about a building system or we're talking about a wood project. Now, if you have a wood project, let's say this is a bookshelf and your final bookshelf looks like that. You're probably, one, you're not going to get many books on it, and two, it's probably not going to last very long. Subsequently, if this is a wall system, studs on a wall are only truly the most effective when they're completely straight up and down. So we're going to show you how to get things squared up and how to get your project square and how to make everything look a little nicer. So let me pause this video and we'll get set up and ready to go. All right, so I reset my mock-up here, and in order to get something square, and by square I mean 90 degrees. So this is an example of a speed square. But you will notice that this is a 90-degree angle. So in construction and wood projects, when we're talking square, we're talking about 90 degrees. We're not necessarily talking about the geometric figure. So in order to get something square, there's a couple things. Like if this is my floor system or this is my shelf project that I'm working on, a couple things you have to have is, one, that you have to have opposite sides have to be the exact same length. So I've got this side labeled A and this side labeled A. I've got this side labeled B and I got this side labeled B. And I actually measured them and cut them the opposite sides exactly the same length. So B is equal to B, A is equal to A. Okay. If your project is not in that configuration where your opposite sides are exactly the same, no matter what you do, you will not be able to get all four corners square. And we'll show you that in a little bit here. But what you can do is, once you've got a project, and let's say I've got this thing and it's on the floor, this is my floor system that I'm going to build, and I want to see if this thing is square. Now, obviously, I can look at this and say, no, it's not. But there's a way to check, and as these floor systems get bigger and bigger, it's tougher and tougher to see, if you are 2 or 3 inches out of square from a great distance. So what you do is you grab yourself a tape measure and you measure your diagonals. And this diagonal happens to be 14.5 inches long. And this diagonal happens to be 19 inches long, just a shade over 19. So obviously I know that this is not square. So what I want to do then is I want to shorten up my long diagonal by bumping my wall or floor system over and then measure it again. So now I'm at about 16 3/4 that direction, and I am at 17 at that direction. So I'm pretty close. So I need to bump it over just a little bit more. Check my diagonals one last time. I'm actually going to cheat a little bit and drag that. And that diagonal is 17 and this diagonal is 17. So if this was my floor system, I could say that the perimeter of my floor system is now square because my opposite sides are the same length and my diagonals are the same length. And there's geometry that you could work. If you have a favorite geometry teacher, you could go ask them about what theorem or postulate you would use to calculate this. But just take it from me, if your opposite sides are the same length and your diagonals are the same length, your system is then square. So I'm going to pause the video. I'm going to put a different piece in here, and I'm going to show you what happens if one of the pieces is not the same length. All right, so I'm back and my camera is tilted just a little bit, so we'll try and straighten that out for you. But you can see that I've replaced one of the pieces, one of my side B's, with what's supposed to be a side C bit because I am not a cinematography major. I'm not a director or producer. I'm winging this baby. So this is actually supposed to be a C, but the way it's sitting, it actually looks like a U, but that is immaterial. So anyway, I replaced this side B with the side C, which is 1 inch shorter than what side B is. So I did put my square in here, and I was able to get this corner square. I was able to get this corner square, but no matter what, I cannot get this corner square, and I cannot get this corner square. You can see that my square leaves a pretty good gap between here and here. Okay, and the reason I can't do that is because I don't have opposite sides the same. So this is the important thing for whoever in your group work is assigned to cut pieces for you. Make sure that, one, they know how to run a tape measure, and two, they know how to run that saw, because if they goof up, and they cut things too short or they leave things too long. No matter what you do, you're not going to be able to get these things square. You're going to struggle. So I want to show you one more piece before we go out into the shop, a really quick demo on a different way to figure out square if you've got a long distance to go. So we'll pause the video, I'll reset, and we'll be right back. Now, when I was a kid in high school, geometry was my favorite math because it was something that I could see. And also I could see that there was a practical application for it. So I really took geometry as one of my favorite classes I ever took. And so I apply the principles in geometry to a lot of what I do. And one of the main areas that I do that is construction and woodworking. So in geometry, we have a theorem. Most of you have probably heard of this, and it's called the Pythagorean theorem. And this guy, Pythagoras, came up with the idea that if you have a right angle, the legs of the right angle, when you square it, so I square it, take the measurement of this one and I square it, multiply it by itself. Take the measurement of this leg and I square it and I multiply it by itself. When you add those two together, it should equal the square root of this hypotenuse, which is the side opposite of our right angle. So that's all well and good. And in the construction site and a lot of times out in the wood shop, we don't have a calculator. We can drag our phone out, but then Mr. Clares gets upset that you're looking on your phone and he says, shut that thing off. And you're saying, I'm trying to figure out Pythagoras' theorem. And there's a much easier way to do that. So the way to do this with both the construction class and my woodworking classes is remember 3, 4, 5. Okay. So if this measurement is 3 units long, let's say it's 3 feet long, this unit is 4 feet long, then this unit between the two has got to be 5 if this is a right angle. So that's an easy way to measure that. Okay, so 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. Take the square root of 25, and that's 5. So we use that a lot when we have a corner that, let's say we've got a building that's 60, 70 feet long, okay? And maybe we don't have a tape measure that long. We don't have one of those nice fancy fiber tapes, but we still need to get the building square. At least we need to get a corner square. So that's a way that you can do that. And I'm going to show you that out in the shop. Now, the last thing I want to say before we go out in the shop is that this works with any unit. So my wood shop students, it works with units of inches. My construction students, it works with feet. It also works with any multiples of 3, 4, and 5. So for example, it works with 6, 8, and 10. If you don't believe me, punch that into a calculator with the Pythagorean theorem. So it works with any multiples of 3, 4, and 5. Keep that in mind, and this gets real easy. So we'll pause the video, we'll go out in the shop, I'll set this up, and we'll do a quick demonstration on how this can save you a lot of time and how you can get a building square even though you may not have 4 corners. All right, so I'm set up back out here in the shop, and I want to talk just about how do you get the building square, maybe if it's a really large building and you don't have one of those big tape measures, or if in the case, and I don't know if you can see that really well, I've got a piece of white paper over the corner of my building to simulate an angled entryway. So maybe I'm having a door enter at an angle instead of coming straight along one of the wall systems. So how do you do that then? You know, I don't have my 2 or my 4 corners where I can pull my diagonals with my tape measure. How do I get this building square then before I start laying down floor systems or I start putting wall systems up? And that's where that 3, 4, 5 comes in handy. So what I'm going to do is I'm going to pause the video again, and I hate doing this all the time, but I'm going to set up so that you can see what I'm working with here, and we'll be right back. All right, so I'm reset my tripod and my camera up so we can take a look at this floor system and how to get things square. So first of all, what I did is right on this system, right over here by my foot, I put a mark at 3 feet. So I measured from this corner, put a mark at 3 feet. Now I also happen to have another mark that goes from this corner over to here, which happens to be the seam of our plywood that we've laid down on our floor system. Now, obviously, now's a little late to be checking our square, but we did this in the shop and we did this in the class together, so we know that this floor system's square. But what I want to show you is how to put this thing square if we don't have diagonals that we can measure, or if the diagonals are just too long. So I'm going to move with the camera this time, and hopefully I don't snag it on anything, to show you what I'm up to. All right, so here again is my mark at 3 feet. And I'll bring that camera up and tilt it down. I got a nice big mark. So what I'm going to do is I'm going to hook my tape measure. I have a little nail over there that I can use to hook onto there. And I'm going to pull right out to this 3 foot mark. So 4 foot and 3 feet. And if you can see my tape measure, and I'll move my screen just a little bit closer and tilt it down, you can see that I'm right at that 5 foot mark. So again, 3, 4, 5 is a fast and easy way to see if this corner is square. So I have this cornered square off. I could do the same thing with my other 2 corners. And with my angled entryway, I wouldn't have to do that. Okay. And again, this works for like bigger buildings, but if I had a bigger building, I might consider using a different multiple of the 3, 4, 5 principle. I might consider using the 6, 8, 10 principle, or I could triple those numbers and I could go 9, 12, and what is that, 15. Okay, so it works with any multiples, it works with any units, but it might be something that would speed this up, especially if I didn't have a tape measure long enough to pull all the way across. So that's it for today. We'll have a couple exercises for you to do related to this and getting things square, whether it's a shop project or whether it's a building system. But again, it's an important place to start, because if things aren't square, everything else gets a lot more difficult after that. So again, until next time, everybody stay safe. Please be well, and don't drive your parents crazy. All right. See you guys.